بسم الله الرحمن الرحيم. إن شاء الله اليوم we are going to cover control structures or statement in MATLAB, mainly the if, for and while statements. زي ما بتعرفوا the sequential way of executing the commands إنهم يكونوا one after the other, like the figure here. So the control, once we finish executing this command, it moves to the next command and so on. If we want to control the control flow, for example, we want some commands to be executed based on some condition or to skip some others. In this way, or in this case, we need to have a statement that allow us to do this kind of branching. ففي عندنا في الماتلاب we have if statement. Before the if statement, it's supposed to be sequential. Once we reach the if statement, we need to, or we will face a test or condition. This condition has to be evaluated. The result of the condition either true or false. If it evaluates to true, in this case we are going to execute commands, some commands. If it is evaluated to false, in this case, or if it evaluates to false, we are going to execute another set of commands. In either case, after executing the commands in this block or in that block, we need to go again into the sequential mode. This kind of statement is called conditional control or branching structure because it allows us to go or to select which branch we are going to follow, the true branch or the false branch. There is also another type of control statement called iterative control or looping structure. This kind of statements allow us to execute, as you can see in these green commands colored. This can be executed specific or we can iterate executing this many times based on the setup we have to do. This setup should also include some kind of testing, because while this true or this setup evaluates to true, we need to go and again iterate and execute these commands. If we are done, this means that the setup finished or it evaluates, the condition evaluate to false. In this case, we are done and we have to go again into the sequential mode. Of course, the difference between the iterative and the branching, here we have two branches in which we need to select based on the condition. Here, while this condition is true or while the setup evaluates to true, we iterate. So this block of commands will be executed many times based on the condition. Here, any of these will be executed one time because we don't have looping. What we are going to have today is how we can write such kind of branching structure or looping structure in MATLAB. Of course, as you can see, both of them have this testing setup. That's why we need to introduce first what kind of expression that evaluates to either true or false. This kind of expression is called logical expressions, as you can see in this slide. And logical expressions are any expression that results in true or false condition. Of course, we need to introduce what kind of operators that help us to build logical expressions. As you can see, we have relational operators like is equal to, not equal to, greater than or equal, less than or equal. And here we can see how these logical operators can be used. For example, if we have x equal 2 and y equal 5, whenever we will see x, we need to substitute with 2, and if we see y, we need to substitute with 5. In this logical expression, it tests, is 3 less than or equal 4? In this case, this is a true. So the result of this expression evaluates to true. Now, if we test this on MATLAB, 3 less than or equal 4, this is how we write the logical expression. The result of this, as you can see, true. The true in MATLAB can be either true or 1. The 1 stands for true, that's why you have this one here. Again, another expression, x not equal to y. We need to test this expression. Of course, since we know that x2, y5, 2 not equal to 5. This is a true. That's why the result should be true. Again, we can go to MATLAB and test. Let x equal 2, y equal 5, and we want to ask, is x not equal to y? The result we get with MATLAB is true or 1. Now 2x, 2 multiplied by x is equal to y. In this case, we have two operators. The logical, the relational is equal to, and the mathematical operator is the multiplication. Of course, we need to know the priorities. The mathematical operators has the first priority, so we need first to multiply 2 by x, so 2 by 2 is 4. Then we need to compare 4 with 5. The 4 equal to 5, this is false. That's why we need to get false. If we test this in MATLAB, we can do this easily since we already initialized x and y. Now 2x is equal to y. Of course, the result, as you can see, is false. Is x greater than y? 2 greater than 5? Of course, we can see again false. Now we have on both sides mathematical expression, the priority for the mathematical expression. So first we need to evaluate the addition, the subtraction, then we can evaluate the relational expression. So the first one, 2 plus 3 is 5. 5 minus 1 is 4. So 5 greater than or equal 4, this is true. And you can test it and check with MATLAB. Now x plus 3 is greater than y minus 1. And the result is true because x plus 3 is 5 as we evaluate, and the right hand side is 4. That's why. And for this expression, this is character comparison. So I want, since we have those single quotes, this means the letter A is less than, alphabetically, less than the capital P. Of course, this is true. And we need to write this expression like this because those are the letters, not variables. Okay? So you will get true again for this. In the next slide, we will see another kind of operators, the logical operators. So far, in the previous slide, we have the mathematical together with the relational, which is greater than, less than, or equal. And now we are going to have the logical operator, which I guess all of you are familiar with, and or exclusive or and not. And this is how they evaluate. So if you have an operand, left operand and right operand, the result will be true if both operands are true. Otherwise, the result will be false. And for the OR, it's enough to have one operand true. That's why false true or true false or both true, the result in OR is true. Otherwise, or it will be false and OR. The exclusive, if we have same operands, same value of operands, it evaluates to false, otherwise it evaluates if they are different to true. That's why false and false XOR false, false. True XOR true, because they are the same value, evaluates to false. While here, since we have true and false, which is different from each other, the result of XOR is true. The not, of course, this is the negation of each operand, so if it is false, we will have true. If it is true, we will have false. Now the overall, and since we have now logical operator, arithmetic operators, and relational operators, we need to know the precedence or the priorities of each operator. And this is summarized in this table. So the higher priority will be for the arithmetic operators, then for the relational, and if we have more than one relational, we need to evaluate it from left to right, then the unary not, then the logical operator, and either written this or that. If we have more than one and, we need to evaluate it from left and right. Exclusive and or, exclusive or and or, we can evaluate. Of course, we can have the pipe for or double pipe for or again. This is the short circuit for the or. This is the exclusive or, and we will see in the next slides how we can use these operators. And the or, exclusive or, will have the lowest priority, and if we have more than one or exclusive or, we need to evaluate it from left to right as they appear in the expression. Now this is exercise just to make sure that we understand the precedence and when evaluating logical expressions. So again, assume we have x2 and y5 as you see in this slide, and we want to evaluate this expression. As you see, we have relational operator, logical operator, which is the and another relational operator. Of course, the first priority for the mathematical, we don't have mathematical, and the second priority for the relational. So we need to evaluate the relational first. X less than 4, 2 less than 4, this is true, and okay, I need to evaluate this is first because this is relational, and the relational is higher priority than the and. So x, which is 2 greater than 2, true. True and true, the result should be true. Of course, we can test this expression on MATLAB. So x, sorry, I need to, less than 4, and x greater than 1. This, so you can test yourself with MATLAB and check your answers. Now, if we want to test that x between 1 and 4, we shouldn't write it like in mathematical format. We need to write it in MATLAB format. MATLAB need, if we want to say x has to be greater than or equal 1 and less than or equal 4, we need to write it like this. This is equivalent to and, okay, x less than 4. This is how we need to write it. That's why in the result column it's mentioned that this is invalid expression. We shouldn't write, if we want to make sure x between 1 and 4, we shouldn't write it like this. We need to write it like this. Okay, that's why the result is invalid for this expression. But if we write like this, we can test is 2 greater than 1, true. Is 2 less than 4, true. True and true, the result will be true. Now we can evaluate this. Is equal, is x equal to 1? 2 equal to 1, false. 2 equal to 3, false. False or false, the result should be false. And now for this, please note that MATLAB consider any non-zero value to be true. So if we are going to evaluate this, not x, x equal 2. So not 2 means not true, because any non-zero, 2 non-zero, evaluates to true. Not true is false. false also in MATLAB 0. So this left hand side evaluate to 0. 0 less than or equal y, which is 5. This is true. That's why please correct this result here. This should be true and evaluate to 1. Of course we can test this on MATLAB to make sure that we did the correct way. This is Control C, and let me check with MATLAB. As you can see, still x equal to y equal 5, and I want to check whether not x less than y. As you see, this expression evaluate to 2. Why? Because not 2, which is x, equals 0. Because MATLAB consider 2 as true. True means 1, not 1, 0. And 0, if we compare 0 value, which is the left hand side of not x, less than 5, this is true. That's why we need to correct this result value here. Now the XOR, it's like function call. So we need to first mention the function. Between parentheses, we add the operands. This means x greater than 5 XOR y greater than 3. This is how we can read it. So we need to XOR these two parameters. Okay. Now x equal to 2 greater than 3. This is false. Y 5, which is y 5 greater than 3, true. So we have false, true. In this case, we have different values for each operand. And we mentioned that in XOR, if we have different, the result should be true. That's why this expression evaluate to true. The last expression, you can see we have is equal, less than, those are relational. Then we have or and. According to the precedence table or priority table, we need first to evaluate relational. So 2 equal to 2, this is true. Okay? So I can write under this, I can write the value. This should be true, or y equal 3, 5 equal 3, this is false. Okay, and 2 less than 0, this is false. Now I have and, or and. Okay, based on the priority table, I need to evaluate the and first. So false and false, false. Then or it with true. That's why I get true as final result. And of course you can check this with MATLAB. Once we know the logical expression, now we can again resume how we can write the if statement, the control structure in MATLAB. We mentioned that we are going to introduce 3 statements, the if, while, and for. First, the if statement allow us to have branching. Okay, that's why they call it a branching structure or control statement. The general structure of this statement, you need to start with if, and you know that MATLAB is case sensitive, so this is if small. Then you can write any logical expression that evaluate to true or false, like those we just had in the previous slides. This expression, if this expression 1 evaluates to true, we need to execute this block of commands, which is immediately comes after the if statement. Okay, if expression 1 evaluate to false, in this case we need to check the else if, and please note that else if is one word. Okay, one word, we don't have space between the else and if. Okay, so if expression 1 evaluate to false, we need to go to the else branch. In else branch, we are going to face another expression, which is expression 2. We need again to evaluate this expression. if this expression 2 is true, we need to execute the statements immediately come after this, which is this block of statement. Okay, if expression 2 evaluate to false, in this case we need to go to the else. In the else we don't have any condition to test, so directly we can execute these commands. And in any case, whether this is true, we get into these statements or that statement, or execute the else branch, we need after this to skip and resume what's come after the end. So what any statement comes after the end, we jump to this after finish with the branch and resume executing these commands after the end. Okay, of course the simplest way of writing if we can have like this. It's only if condition with true branch. Okay, for example, I can write if x greater than 0, display or write positive, display positive. Okay, otherwise or without any otherwise, end. This is the simplest way of writing if statement. You can have if condition and commands with end without any else. This means if we have x and we evaluate the expression and it evaluates to true, x in our example 2 greater than 0, yes. In this case MATLAB will execute this statement, so it should display for me positive. Then oops, oh sorry, I didn't complete the command. Display positive and n. Okay, since we have x evaluate to x value is 2 greater than 0, this expression evaluated to 2, it should get inside the if statement and execute this statement for me. Then comes after the end statement. Okay, if x equal, for example, -1, in this case, if we are going to repeat this if statement, it shouldn't get inside the if statement. Why? Because -1 greater than 0, this is false. False means jump, see if you have any else or else if. Since we don't have anything, we need to jump outside the end. So in this case, let me check. This is x equal -1, and let me repeat the if statement. We check for positive numbers to display this message. Control V. Now see, we didn't have any displayed message. Why? Because x equal -1. -1 is not greater than 0. In this case, the expression evaluate to false. And since I don't have inside this if any else or else if, so I cannot test any other thing. I just jump outside this if statement, executing nothing. That's why it doesn't display anything for us. Okay, so this is the simplest way of if. If you can have condition, if this condition evaluated true, you can execute some statements or block of statements. Otherwise, you can jump outside the if statement. This is the simplest if statement, use of if statement. Of course, we can generalize it. If you want to generalize it and have multiple expressions to be evaluated, in this case, assume this is the start of your if. This is the first expression, the first condition which you need to evaluate. If the condition evaluated true, you need to, the result is true, you need to execute the commands, immediately follow the if. And after that, once you finish, you need to jump outside the end. Okay? But if the condition evaluate to false, in this case you can see if you have else if. The first else if statement should have condition. Again, you repeat the same process. Evaluate the condition. If this condition evaluated true, you need to execute the commands or the statements immediately come after this else if. Otherwise, if this is false, you need to see whether you have other else if or you just have an else. Okay, if you have just an else, you need to go, of course, since you don't have any condition to evaluate, you need to go inside the else and evaluate these statements. And in any of these cases, once you get inside any of these branches, the next job for you is to jump outside the if statement. Okay, of course we need example to understand this. Before we start with the for loop, let us take an example to see how the else if evaluate. So assume we have x, and I'm going to run this program several times giving different values for x. Okay, so if I have x10 and I want to check if x greater than 0, I want to display positive. And else if, okay, now if this x less than 0, okay, I want to display negative. Otherwise, I don't have to check, it should be 0, okay? That's why I will write otherwise else. I can safely display that, okay, I have 0 number, so n. Now we can run this program and see, according to x value, it should evaluate the first condition, okay? And since the first condition evaluated true, it should display for us positive, and it should go immediately outside after that, outside the if statement. That's why I will display message here just to make sure that we get out of the if end test, okay? This is just to make sure that if MATLAB display this for me, this means that it comes to this statement, okay? First we need to save the file. This is exercise, okay, and run. We can of course clear the screen if you want to just have fresh start. See, since I have x equal 10, the if statement, the first condition is x greater than 0. This is true. That's why it's execute this statement for us, and we see positive. And we need then to skip or to jump outside the if statement. And the first statement after the end is display and test. That's why we get this. Now let us change. Assume we have minus 10. Okay, you can predict we should have negative message plus end text test. Okay, see, negative end test. And if we change it to 0, in this case I should get 0 and end. So that's why they call it a branch, because in any time only one of these branch or one of these blocks will be executed based on the condition. Then it resumes the sequential execution. Okay, I hope I make it clear for you. Now the for loop. As we mentioned in the first few slides, for loop is an iterative control statement. In MATLAB, the for statement need to be written like this: for, small letter, we need to have variable equal some vector values, okay, numbers, okay, any vector of values. And as long as I have the variable can take or instantiate a value from this vector, I need to execute this code block. So we need to iterate as long as there is values in this vector for this variable. Okay, that's why if we look at the flow chart, first we need to test, make setup for the for statement. As long as still we can have value for this variable, we need to do some kind of computation or statements or commands, whatever. Okay, and we need to iterate in this loop. Once we finished, means we finished all values in the vector and we don't have any new value for this variable. This means we are done, and in this case we need to go outside the for loop. In this slide we can see this is example in for loop. For, okay, index I and D. This is one variable name equal 1 to 2. This is the vector values. Okay, and you can from this command you can see that we need to compute the sign of this index, but after dividing it by 10, and we need to make a vector B from these sign values. Okay, if we copy and paste this into MATLAB, Control V, oops, because we don't have semicolon, you know, the echo. Okay, so the first is the for index from 1 to 10, then P of, yeah, this is the missing column. That's why we have this 100 echoed value, because each computed sign, we don't have semicolon. After storing it in P of this index, it will be echoed on your screen. End. Now we will not have any echo, but you can check from the workspace that, oh, now you have a new vector P, okay, of 100 value of sign, okay, computed from this index after dividing it by 10. Of course, from our previous knowledge in MATLAB, we know the vector notation, and we used to compute sign for many values in one single statement. So we can avoid this for loop if we write like this: index equal from 1 to 10 or to 100, sorry, and B is equal without having this index. And now, since index now it's a vector, see, it's a vector of 100 value, 1 to, see, to 100. Okay, I have it as a vector, and I want to compute the sign for this vector in one single statement. B equal sign this index after dividing it by 10. Of course, since this is element-wise division, you can have the dot, okay? And this is my P. Okay, it evaluates to the same values. So instead of having this for statement, you can use the vector notation, and this is much faster than the for loop in MATLAB. So if we look at the note here, of course, in this example, the index changed to x, and x is equal 0.1 with increment step 0.1 up to 10, because each time he wants to get rid of this division by 10. But we can divide 1 by 10, okay, because if index equal 1 over 10, this is the 0.1. If index equal to 2 over 10, 0.2. So the increment is 0.1. That's why we have this step 0.1. And 100, the final value, after after dividing it by 10, you will get 100 by 10, 10. That's why if we prepare a vector 0.1 with increment 0.1 up to 10 and compute sign directly for this vector, you will get the same result. And of course you can check. Okay, you will get same B values. Most loops, as you see in this node, can be avoided. Okay, if we look at this is the while loop. While is very similar to the for, except it's more general by having any condition here. So while x less than 10, you can evaluate do whatever you want of computation, and of course every while needs an end, like the for statement, like the if statement in MATLAB. But you want to make sure that the while loop will reach an end, otherwise you will get into infinite loop. In the for, you already have the limits of your for, so you know you need to start from 1 and your stop is at 100. Here it's while x less than 10, so you need to update x. So I don't think this will run safely in MATLAB, because you don't have any update for x inside the while loop. So if x equal 2 less than 10, you will be trapped inside this loop. Okay, anyway, when we see the while, we can have a better example of while statement. This slide, please, you can reorganize it like this. Okay, so those are the control flow statements, the if, the for, and the while, and those are examples. This is example on the very similar to the positive, negative, or 0. This is just saying greater, less than, or equal. And this is for loop. And if you look at this for loop, it has loop variable x runs from 1 to 10, and each time you just take this x and store it in R. So you have a copy of x inside R. That's all. Of course, you can avoid using the for if you write like this. Let R equal, first if you want to define x equal 1 to 10, okay, then R equal x. That's all. Okay, so these two lines equivalent to this for loop. If you like, you can test this on MATLAB, so please don't accept anything until you try it on MATLAB. Okay, so I have here, I need to make it small because it will give me, this is the for, this is R, and the end of my for loop. So I need to see a new vector R, which has the values, this is R, which has the values from 1 to 10. This is the effect of this for loop. Okay, and this is really equivalent. You can just write R equal 1 to 2, 1 to 10, like simply like this, or you can prepare it in x equal 1 to 10. Then make a copy inside, let R equal x. This is another way, and all should lead to the same result. See, still R from 1 to 10. In this slide, it asks us to run and find the output of the following statement. So let us first trace it before we copy it into MATLAB and see what it should give us. Okay, so I equal 6 and j equal 21. 6 greater than 5, this is true. So k will have a copy of I, so k equals 6, and it will jump outside this if statement. And of course you can just copy this into your MATLAB, Ctrl C and see, is k equal to 6? Let me clear the screen. This is Control V. Now see, this is your K. It's 6, and you can just display K and check if you don't want to go inside the workspace. Of course, if you change, if you want, for example, K equal to 1, if you want the MATLAB jump to this statement, in this case you want to make sure that you have values for I and j which makes this false and this false, then it will come to this statement. So what makes this false? I can choose, for example, a 3 for I. So if I have I with value 3 greater than 5 false, 3 greater than 1 true, but 21 equal 20 false, and true false. In this case, I will have K equal 1. Okay? But you can try different values for I and j and see what the MATLAB will give you. Those are examples, just generalization. It mentioned to you that you can have as many else if statement as you want, but you have only one else part. Of course, the simplest way is to have if without any else if and else. You can have one else if, you can have if with else, okay, even without any else if. But you should know, if a less than 5, we need to do some MATLAB commands. Otherwise means you can convert this to else if this is the complement of this condition. So otherwise means else if, not the first condition, which means a greater than or equal to 3. So you can write it like this, or you can just keep it. If it is the complement condition, you can just keep it with else. This is up to you. Okay, but you need to know every else, if you have like this, if else, can be converted to else if, but by having the complement of this condition inside. Now the while loop. The syntax of while loop, while condition, you need to do some commands, okay, and you need to have else. Of course, case sensitive, so the keywords while and need to be small letter. This is example. You can have any logical expression which evaluate to true and false. So while true, execute these commands, okay. Once this expression evaluate to false, you need to go outside the loop. Of course, that's why inside this block you need to have some statement which update on this condition. Otherwise, you will be trapped into infinite loop. Sorry. Those are examples on the for loop. So this is the one we've just seen in the previous slides. For I equal from 1 to 100, or you can specify the increment. You can have j equal from 1, each time you need to increment to 3 up to 200, or you can have even real or negative numbers like this, or specific values. This means, for example, for k equal 0.1, 0.03, minus 13, 12, 7, minus 9.3. Those, if you count, you have in this vector 1, 2, 3, 4, 5, 6 values. This means this block of a statement need to be executed 6 times. Each time k will have one value from this vector. So k will be first 0.1, this is the first execution, k equal 0.3, the second, k equal minus 13, the third, k equal 12, fourth, k equal 7, fifth, k equal minus 9.3, the sixth iteration. Okay, so this is depends on the question or the problem you are going to solve. But this shows you the flexibility for having the variable, okay, and the vector values for the for loop variable. This is exercise. This exercise asks us to print out the values, okay, of 1 over m plus 1 when m takes the value between 1 and 10 inclusive. Of course, according to the question text, the counter in the loop can also be given by an explicit increment. Of course, as we just seen, this means that you can have counter I equal from m, each time you need to increment k up to n. This depends on the problem, okay, to advance from start to the k step till we reach the end, which is n. For this specific equation, you can have this solution. For m equal from 1 to n, the number, okay, or the output equal 1 over m plus 1. If you ask yourself why we don't have the dot operator here, because m is variable, this is not a vector. That's why we don't have to have the dot notation. And you can test this on MATLAB and see the result, okay? Control V. This is the result, and you can check that you have 10 different values for number. When m equal 1, 1 over 1 plus 1, 2. This means half. That's why you have half, and so on. You have 10 different values. But if I want to avoid using 4, how shall I write? I can have m equal 1 up to 10. This is vector now. This is not loop variable. This is vector. See, this is your m. It's vector. 1, 2, 3 up to 10. Now, if I want to create number, I need to have the dot operator. Otherwise, I will end up with syntax error. M plus 1 semicolon. See, this is your number. Exactly the number that we just displayed on the screen. If we are going to avoid the 4, you need to know that if you have any vector inside arithmetic or mathematical operator, you need to make sure whether this is element-wise division or multiplication or matrix. So in my case, it's really an element-wise division. That's why I need to use the dot operator. If I forgot to write it, okay, see, you will get an error because this is element while this is vector. So you cannot divide like this. You need to have the element-wise, because each number inside this m, you need to add 1, then divide it by 1. Okay? Nested for, you can have also nested for. For this example, you have two loops, the I loop and the J loop, and you don't need to have every time to start from 1 and to 10. In this example, we start from 2 and to 5 and 3 to 6. And A is a two-dimensional matrix which need to keep I plus J to the power 2. And again, we don't have to have the dot because those are variables, not vectors. Okay? So what happens really, I will take the value 2, J will take the value 3, then A of 2, 3 will be 2 plus 3 to the power 2, which is 25. And why we have this 25 here inside, not in the beginning or here or there? Because the index in matrix A was 2, 3. 2 means this is the first row, this is the second row, this is 2. And the 3 means the third column. That's why we store the first value here. What about those empty location we didn't access? Okay, of course by default will be 0, and of course if you want to check, you can have this copied into your MATLAB and see the result. Okay, this is the result. So those wasn't accessed inside the loop, that's why they remain 0. And those are just squaring the index, the row and the column index, not starting from row 2 index or column 3. Then what happens, we need to finish the J loop. J will be 4, 5, 5 up to 6. Once we finish the j, in this case this statement will end and still I equal to 2. Then we go to I variable and have another value for this I, 3. Again we go inside the j, we start again a fresh start. I equal 3, but j start from 3, 4, 5, 6, and so on, and you will get this output. This is another example, but using while statement. Okay, as you see from this comment line, this finds all the powers of 2 below 100. But if you copy this into your MATLAB, you will find that you will have 128 inside your result values, and we will check together why we'll get this. Control C. Okay, let me clear, close. If you want to clear this working space, you can have clear all, and that's all. CLC, sorry, Control V. Okay, I have this error Y, and this is initialization. Yeah, it's only because this is the Y, maybe because it's copied from the slides. V equal, num equal, yeah, just shift with 6, just rewrite it, that's why it appears in a different color. Okay, V, and this is the increment of the counter, and this is your end. Now check the V vector. It finds for you the powers of 2 up to 128. Why? Because initially number equal 1, I equal 1, and V equal 1 according to the initialization line here. Okay, 1 less than 10, yes. When we get inside the loop, since this is true, 2 to the power I, which is 1, 2 to the power 1 equal 2. Now this is concatenation, but this is column concatenation because I have semicolon here. Because of this semicolon, that's why the result appears like a column vector, not a row vector. Okay, of course you can try and have comma, and you will see that you will end up with a row vector. In this case, this means 1, which is the value of the first value for V. We want to concatenate it with making a new vector after adding num value. Num equal 2, so we'll have 1, 2. And now V will be vector, not variable, single value variable. I equal I plus 1, I equal 1, 1 plus 1, 2. Again, we need to check the while. Is number 2, the last value, sorry, for one number is 2 after evaluating this. So here, when I check number 2 less than 100, true. Again, I need to go inside. 2 to the power I becomes 2, or became 2. So 2 to the power 2 is 4. Again, I have already 1 and 2 inside V. I need to add 4. And if you look at the value just before the 100, it's 64. So let us assume we already finished and we reached 64. Okay, now 64 less than 100, yes. 2 to the power I, okay, 2 to the power it should be 7. Okay, 2 to the power 7, it gives me 128. Then we concatenate, then we find that the number is greater than 100. That's already, it's fine for us, sorry, to the power 8. It's fine for us that 128 is stored, then the check evaluate number and find, oh, this is false, and it jump outside the while statement. That's why we need to make sure that we properly check the end condition for the while statement. Okay. In this slide we can see how we can, we already had this in first part, how we can write user-defined functions. This is again just like revising how we can write function squarer. Assume we have this task. We want to write a function named squarer. This function will accept parameter, which is maybe variable, matrix, whatever, and indicator. The indicator, it is an integer number just to let me check whether I need to do square or element-wise square. Okay? And the result after squaring or element-wise squaring, I need to keep it in this parameter called out. Of course, any function in MATLAB need to have function, keyword, and its prototype. This is the output parameter, equal, the name of the function. Those are the input parameter. Of course, according to the indicator, assume I have int. So if int equal 1, I want to do the square. Else if the indicator equal 2, I want to do the element-wise dot to the power 2. You may ask yourself, why do we have equal 2, not else? Because the user may send you 3, 4, 10. In this case, you can just display this is invalid or whatever kind of error message you can display to the user. Okay? If you like, we can write this on MATLAB and see how we can call this function. Function need to be written in a script file with saved under the same name of the function .m. So function you can have any name here. It shouldn't be X, Y, Z, whatever. This is the result, the output, squirrel. This is the input parameters. Okay, and I want first to check the indicator. Is it equal to 1? If this is true, I want to do the to the power 2. Else if the indicator equal 2, I will do the element wise. Okay, and now we need to save it. See, it suggests for me the name of the function, so save it. Now to run this code, I need to prepare something. I can call it like this. I want to see the result of a square. See, it gives you the hint. This is the parameters for the square function. You can send 12 and the indicator is 1. In this case, it consider this as a square matrix of 1 by 1 and it do the square for us. And if you have a different like this 1, 2, okay, semicolon, 3, 4, you can send matrix and you can have element wise if you have the indicator 2. In this case, see 1, the square of 1, 1, the square of 2, 4, 3, 9. Of course, I mentioned here the parameters explicitly. You can prepare them in variables like this. You can have let x equal 1, 2, 3, 4, like this. Then you can see the result, not explicitly mentioned using the variable x. Again, you will get the same result. In this slide, this is the last topic. It's about solving linear equations, okay, using back divide method. The back divide method in MATLAB, this symbol means back divide method. In order to solve system of equations, you will have like this linear system of equations or variables, and we need to know what's the value of x, y, and z that makes all of these equations correct. Okay, this is what we mean by solving linear system of equations. In MATLAB, this is very easy. It's simply in one statement like this. But first, you need to prepare what's the coefficients, what's the results, and it will find for you the variable vectors. So the first step, we need to get out those coefficients: 5, -3, 2, -3, 5, 4, 2, 4, -9 into a vector, a matrix. This is the A matrix, the coefficient matrix. This is 5, -3, etc. And B, if I return back to the slides, B is the results of each equation, 10, 29. So this is your B vector, and you need to make sure that the dimension, this is vector notation, column, okay. Then you can have this very simple back divide method, and you will end up with x vector, which is the variables. X doesn't mean that this is only this x. This is 3 values for variables, and the variables we have x, y, and z. So the first value should be for x, the second for y, the third for z, and this is vector, not single variable. Okay, so don't please misunderstand this x and think it's only this x in the equation. No, we have one x for all of these x's, one y for all of these, one z. This is how we solve linear equations. Okay, this is another exercise. Minus x plus y plus 4 minus 2 equal minus 2, 2x plus 3x minus 2z equal 3, 3x plus 3y equal 4. Of course, if you don't have any variable which appear, this means the coefficient is 0. That's why, see, when A, the coefficient matrix, you have 0 here. Of course, those are 3 variables with 4 equations. Okay, so you need to have 3 rows, 3 columns with 4 rows, and this is the third equation. The coefficients here 3, 3, 0 for z and 4. This is 3, 3, 0, and the result in B should be in B vector. And of course, if you have this back divide, you will get the value for x, y, and z that makes this system of equations correct. Okay, another way, as in this slide, if A is a square matrix, okay, you can find the inverse and multiply it by V, and you will get the same result. Of course, here A, if you check, you have 3 columns, but you have 4 rows. You can get out or get rid one of these rows and try and see, of course, one of the values from here. So if you have 3 by 3 and 3 by 1 B vector, you can use the inverse and find the solution using the inverse, not by calling the back divide. So you have both ways, but this works, the inverse works only with square matrices.